Okay, this is day 2 of Slope-Intercept Form Section 8. So this is page 39. I've crossed out a few examples because I feel like we did a lot on day 1 and I want to kind of move through day 2. So what I'd like you to do is let's move down to the very bottom example to start with. So yesterday what we discussed, or in the prior video what I discussed, was graphing in the form of y equals mx plus b. So yesterday we asked, or the previous video we said, am I in slope-intercept form? So when I look at this equation, it is not in slope-intercept form. So we are going to have to solve for y to start with. Or another way we call that is putting it in slope-intercept form. So I'm going to rewrite the problem down here, and I'm going to solve it for y. So remember, that's the process where we move the x over. So I take away x from both sides. So I now have 3y equals negative x plus 9. And then now I need to undo and get rid of the 3. So divide everything by 3. So that gives me y equals. Now remember, there's a 1 in front of this x. In fact, it's a negative 1. So negative 1/3 x plus, and that's going to be 3. Now remember, we're looking for the m and the b. So my m is negative 1/3 and my b is positive 3. So when we graph, we begin with the b. So start with the 3 on the y-axis. So 1, 2, 3. And then my slope, remember, is rise over run. So I'm going to count down because I have a negative. So from the dot, down 1 over 3, and keep going. Down 1 over 3. Down 1 over 3. And for good measure, go back to the original y-intercept and go up 1 and the opposite direction 3. So let's connect, make your line. Okay, so in order to identify x and y intercepts, I do have dots on both axes. So my x-intercept is right here, and that's at 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And my y-intercept, I don't even have to really look at my graph, it's at 3. So 0, 3. Now, if we couldn't see it, this is when we plug our 0 in. All right, so let's move on. And I'd actually like you to do this one next. So if you would go ahead and pause the video here, and then when you come back, I will kind of step you through the process. So go ahead and pause. Okay, on this problem, you first needed to solve for y. So that equation is y equals negative 3/2 x minus 2. Your slope is negative 3 over 2, and your y-intercept is negative 2. So I started at negative 2 here, and then since I have a negative slope, I'm going down 3 over 2, down 3 over 2, and then I always have you go back and go the opposite direction. Y-intercept is very easy. It's right there on the picture. That's what I used to graph. X-intercept I couldn't quite see, so I had to calculate it. I plugged in a 0 for the y variable up here, and then I solved and got approximately negative 1.3. Okay, so what I want to do next is I want us to look at special types of lines. So when I look at these equations, they're a little different. There's only one variable, but they do produce lines. All the equations will make some sort of graph. So the easiest way to graph special types of lines, I'm going to write here, make a table of values. So that was our XY chart. So when I make a table of values here, for x equal negative 4. The only requirement is x must always be negative 4. So I'm going to write down negative 4 3 different times in the x column. My y coordinate can be any number. So maybe I'm just going to go with 0, 1, and 2. So I then can graph these 3 coordinates. coordinates, or these are ordered pairs. So negative 4, 0 is 1, 2, 3, 4 right here. Negative 4, 1 is over 4 up 1, and negative 4, 2 is over 4 up 2. And so you can see that what I'm going to get here is a vertical line. So I'm going to go ahead and graph that line. And so when I look at that, my x and y intercepts are pretty easy. My x-intercept is right there, negative 4, 0. But my y-intercept, since that line's parallel, it's never going to intersect it. So my y-intercept is none. So remember, don't write 0 because 0 is at the origin and it's not going to touch there. So the opposite is true when it's just y equals 10. So when I make my t-chart, my table of values, y must always be 10. So I'm going to place 10 in 3 separate spots. And then x can vary. So 0, 1, 2 would work just fine. So 0, 10 is up here, 1, 10 is here, and 2, 10 is here. So there is a horizontal line. So you could, once you get the hang of these lines, you could start to memorize exactly where it will be. So y equals any number will be horizontal through that number. X equals a number will be vertical. But for now, go ahead and make your table. So our x-intercept here is none. It is not going to touch the x-axis. Our y-intercept is right there at 10, so it's going to be 0, 10. Okay, moving right along. Let's finish up here with a couple examples. I want you to cross out U3S8. It's the same as example 2. So I think what I'd like to do here is look at, I don't think I want to look at all of these. How about we do, let's just do the first one. And then if you want to try the last two, I can go ahead and show you those solutions. So when I want to write the equation, you're thinking y equals mx plus b. So my equation, I need the slope and the y-intercept. So when I look for slope, I want to count rise over run. So my m is going up 1 over 2, up 1 over 2, up 1 over 2. So that is in the form of 1/2, up 1 over 2. Then the y-intercept is right here at 1, 2, 3, 4, positive 4. So when I fit that into this equation, y equals 1/2 x plus 4. Now for my intercepts, my y-intercept is right there, and I can see my x-intercept is right here. So my x-intercept is at negative 1, 2, 3, 4, 5, 6, 7, 8. So negative 8, 0. And my y-intercept is up here at 0, 4. Okay, so I'm going to go ahead and stop the video, or I'm going to pause it. And if you want to try to do example 2 and then you try number 1, go ahead. And then I'll have a solution up here when you come back to the video. Okay, here's example 2. The equation is y equals negative 3x minus 1. My y-intercept was visible at 0, negative 1, but I had to calculate the x-intercept by plugging a 0 in for y and then going through the math, and I got negative 0.3. It's really negative 0.3 repeating. And then, let me get the other one in here. The second problem down here, not do this one. The second problem is the equation y equals negative 1/2 x plus 2. And if you need to zoom in on the video, you might do that. The slope is negative 2 over 4, which reduces to negative 1/2. And then both intercepts are on the graph. So 4, 0 for the x-intercept, 0, 2 for the y.